doing this experiment, when we perform this experiment, you are going to learn about few things. There are few purposes for performing this experiment. First one would be studying law for conservation of mass. Basically, we start with copper. We change the copper to copper nitrate to copper hydroxide to copper oxide to copper sulfate. Then from copper sulfate, we are going to get back to copper. Ideally, if we start with 0.5 grams of copper, we have to end up, we should end up with 0.5 grams of copper if we don't lose the copper in any step. And you are going to cycle the copper through set of these reactions. By doing that, you learn about lab technique, also study the law for conservation of mass. To get the mass of the copper, there's going to be 0.5 gram copper. 0.5 grams of copper. And the next step, we are going to add nitric acid, and I'm going to have to do this part of the experiment inside the fume hood, and you record your observation. You're going to add 5 milliliters of concentrated nitric acid. Nitric acid is the only acid that can actually dissolve copper or react with copper. So if you see from there, the brown color gas is coming out. I hold it up to you. It's a very toxic gas. It has to be done in the fume hood. The fume hood is not acting strong to me at this point. Otherwise, it should have just pulled up. So we have that brown color gas. We're going to leave it there, make it stay there until that reaction is complete, because we don't want to bring the beaker out and get the gas, toxic gas, inhale the toxic gas. It's dissolved. So next step, adding water. 100 milliliters of dry water, because I have 50 ml graduate cylinders. I'm just going to add 2 of the 50 to make it 100 milliliters of dry water. The brown gas is gone, so I can now show it to you. Blue color solution. We had copper plus nitric acid. That gives this blue color solution. It's all clear. Next step, we are adding 30 milliliters of sodium hydroxide, 3 molar sodium hydroxide. And I want you to record the observation, what is happening by adding sodium hydroxide to the copper nitrate solution. See the color change? Is a darker color. At the same time, it turns cloudy. And what is turning cloudy is actually insoluble copper hydroxide precipitate. So copper hydroxide form, and it gives that precipitate to you. Next step, and at this point, you need to follow the procedure to look for the steps. I hope that you already have your lab manual, because you need to have your lab manual in order to write the procedures or to read the procedures. For the next step, we are going to heat up the solution. We heat up the solution. I'm going to use a hot plate. You could use hot plate or Bunsen burner. Either one would work. I'm using the hot plate. Occasionally, I will mix and stir the solution. How long I'm going to heat it up is until the shade of the blue color goes in and it turns to black color. So black color basically is the copper oxide precipitate. So we're changing from copper hydroxide to copper oxide. So when we have the copper oxide solution, is decanting. Let's say you have a mixture of solid and liquid. We've done this technique before, we've used it in the past. When you have a mixture of solid and liquid in one beaker, then you have 2 ways to separate the solid from the liquid. Either you set up filtration apparatus, which we are going to practice today, filtration with gravity filtration, also with different step of the experiment. The other method would be decanting. So you let it settle down, you have the clear liquid on top, and you have a cloudy or more condensed and dense part of the mixture at the bottom. Then you are going to pour off the clear liquid without getting any of the solid into the receiving container. The beaker is going to be good. You hold your stirring rod with a 45-degree angle against the tip of this, or this designed area of the beaker has this designed transferring part of the beaker. So when you are transferring, you basically transfer from here, not from this side, because this side is going to give like more of a backsplash, but here is easier to transfer. So then you would pour it over the stirring rod while you are holding with 45-degree angle. Only the clear portion on top without getting any of the solid into the other beaker for methods for separation. That's why I said that earlier. We are going to learn about some techniques when we perform this experiment. Sulfuric acid ready for later. When I'm doing when is that part of the experiment? Basically, part 4 of the experiment, I need my sulfuric acid. I have 2 grams of zinc, also ready to go. For gravity filtration, bring a stand, a receiving container. We need the iron ring. It should be small enough that when I place the funnel, it doesn't fall through, because we have different sizes. To set up the height of the ring, it should be in that the stem of the funnel is inside the beaker. Because it is up high here, when I try to filter, this can move around and it can splash around away from the beaker. But when it's inside, if it moves around, it's going to hit the wall of the beaker, and as soon as it hits, it gives me a warning that be careful, you're splashing the solution out. So, filter paper is needed for gravity filtration. To prepare the filter paper, we're going to fold the filter paper in half, fold it again in half. We open one part in one side, 3 parts in the other side. So basically, we are making a paper funnel here. We're making paper funnel. We place that inside the glass funnel. For this procedure, we need to have the mass for filter paper for your data sheet. So I'm going to record the mass before I place in the funnel. 0.913 gram is the mass of filter paper. In order to make it stay still, you can add 3 drops of water. You add 3 drops of water, you add 2 drops. It will make it wet and stays still. Okay. The color, the blue color is gone. We have black color precipitate now. I can stop the heat. Okay. Can stop the heat and let it stay. See, the blue color is gone completely. Let it stay. We change the copper hydroxide to copper oxide by applying heat. In the top solution, we might have some extra sodium hydroxide now. We could have anything that is soluble other than the copper oxide. Everything that we added so far is going to be there. So we add the nitric acid to copper. We add sodium hydroxide. So it could be like sodium nitrate left over. We could have extra sodium hydroxide, or any soluble compound that is in this mixture is going to be in the top clear solution. The bottom part of the solution is going to contain, which is more cloudy, is going to contain the copper oxide. And that's what we need for our next step of the reaction. So we only need the copper oxide. So we try to get the top part out. Stirring rod with a 45-degree angle. I'm only pouring the top portion, which is, if you can see from here, which is the clear solution without getting any of the solid in. So when I see the solid is going in, I stop and I can continue with some of the, oh, this is actually enough. So to this solution, or to this mixture rather, not the solution, this mixture, trying to get as much clear solution out. So to this solution, I'm adding the sulfuric acid. So when I add the sulfuric acid, copper oxide is going to react with the sulfuric acid, and it forms a blue color solution. Now, this blue color solution is copper sulfate. Is different from the other solution, blue color solution we had earlier. That was the copper nitrate. So we have the copper sulfate now. With the copper sulfate, we are done with part 4 of the experiment, and we are going to do part 5 now, from copper sulfate to recover the copper. To recover copper, we add the 2 grams of the zinc that I measured already into the copper sulfate solution and let it react. I have to show you the reaction that is taking place. Then I place it in the fume hood just in case if there is like hydrogen gas coming out too much, I don't want to inhale it. Zinc is gray color, and if you could see this powder that is down here, especially the flakes, they are reddish color. Those flakes that are forming now is the copper that is coming out of the solution. If you look at the color for blue color solution also, is going to be fading out over the time. So we get less of the blue color. The blue color is coming from copper sulfate. Copper sulfate has blue color. When zinc goes into the solution, copper comes out. You don't have copper sulfate anymore. You have copper plus zinc sulfate. So the gas that is forming is a hydrogen gas. It bothers me. I'm going to